Dear students, my name is Vaishali and we are studying the subject Fundamentals of Computer, in which we are studying the first chapter, that is Introduction to Computers. In the last lecture, we have discussed about programming languages. What do you mean by programming language? And three different types of languages, that is machine level language, assembly language and higher level language. We have also discussed the advantages and disadvantages of all the languages. And we discussed the concept of memory unit. What do you mean by memory unit? What are the different types of primary memory and secondary memory? So today we are going to learn about the number system, different types of number system and conversion of one number system into another number system. See, there are four types of number systems: binary number system, decimal number system, octal number, and hexadecimal number. We have to learn the conversion from decimal to binary, decimal to octal, decimal to hexadecimal. Means conversion from decimal to other number system, as well as the conversion from other number system into decimal number system. So first of all, decimal number system means it consists of total 10 digits, and that 10 digits are from 0 to 9, means from 0 to 9 there are total 10 digits. So this number system is known as decimal number system. The base of this number system is 10. Base, or it is also known as radix, is 10, and this is the regular number system which the user used to communicate with the computer. The another type is binary number system. It consists of only two digits, and these two digits means 0 and 1. Only these two digits are allowed in binary number system. And as there are only two digits, the base or radix of this number system is 2. Then octal number system. Octal means 8. It consists of total 8 digits starting from 0 to 7. Total 8 digits, 8 numbers are included under this system, and the base is 8. And last one is hexadecimal number system. It is the combination of two words, hexa and decimal. Hexa means 6 and decimal means 10. So there are total 16 digits in this number system, and these 16 digits are from 0 to 9, and from 10 to 15, A to F, these characters are allocated, and the base of this number system is 16. Now we'll see conversion from decimal number system to any of the other number system, means from decimal to binary, decimal to octal, and decimal to hexadecimal. So for converting decimal number into So to convert decimal number into binary number, we have to divide given decimal number by 2. Why by 2? Because you have to convert it into binary. So divide the number by 2. Then write down the corresponding quotient as well as remainder. And we have to repeat this process till we get the quotient as 0. And as we get the quotient equal to 0, we have to write all the remainders in a reverse order. Means from bottom to top, we have to write all the numbers. Then we will get the number in the forms of ones and zeros, that is binary number. Similarly, to convert the given decimal number into octal number, as we know, base of octal number system is 8. There are total 8 digits in this number. So we have to divide given number by 8. Again, here you have to write down corresponding quotient as well as remainder. And we have to repeat this procedure till we get the quotient as 0. And then write the remainders in a reverse order from bottom to top. And from decimal to hexadecimal. In hexadecimal, there are total 16 digits. So we have to divide given decimal number by 16. Here also you have to write down corresponding quotient as well as remainder. But here you have to take care that we have to write down the remainders from 0 to 9. But when the remainder is 10 or 11 or 12, at that time we have to write down either A, B, C or A, B, C, D, E, F. So while writing the remainder, if there is a 0 to 9, no doubt you can directly mention it. But it is 10, 11, 12, 13. At that time you have to write down as A, B, C, D and so on. Here also we have to repeat the procedure till we get the quotient at 0 and write all the remainders in a reverse order. Now we'll see how to convert any other number into decimal number system. See, we have discussed how to convert decimal to binary, decimal to octal and decimal to hexadecimal. Here we have divided the given number by corresponding digit, means by either 2, 8 or 16. But while converting into decimal number system, we have to multiply it by the powers of 2, means from binary to decimal, we have to multiply the digits from 0th power of 2, means first digit we will multiply it by 0th power, then first power, then second power, then third power and so on. Then we have to do the multiplication and then do the addition of all the elements. Similarly, for converting octal number into decimal number, we have to again divide the given number with the 0th power of 8 because it is an octal number. So, we have to multiply it with 0th power of 8. Again here multiply the corresponding elements and take the addition of all the elements. Then from hexadecimal to decimal. In this number system, you have to multiply each digit by 0th power of 16. Means firstly you have to divide by 0th power of 16, then first power, then second power, then third power and so on. Then multiply corresponding elements and then addition of all the elements. We will get the decimal number. So student, today we will see how to convert the given decimal number into binary number system. For example, the number 375, this number is given to you. The base of this number is indicated by 10. 375 base 10 and you have to convert it into binary, that is base 2. So first of all, write down the number, then divide this number by 2 and write down the quotient as well as remainder. So 2 ones are 2, then 2 eights are 16, 2 sevens are 14. The remainder is 1. Write down the remainder. Then again divide it by 2. 2 nines are 18, 2 threes are 16. 2 nines are 18, 2 threes are 6. Remainder is 1. Again divide it by 2. 2 fours are 8, 2 six are 12. Remainder is 1. 2 twos are 4, 2 threes are 6. Remainder is 0. 2 ones are 2, 2 ones are 2. Remainder is 1. 2 fives are 10. Remainder is 1. 2 twos are 4. Remainder is 1. 2 ones are 2. Remainder is 0. And here again, if we divide it by 2, the quotient will become 0 and remainder will be 1. As soon as the quotient becomes 0, we have to stop this procedure and write down the numbers from bottom to top. So we have to write down the numbers in a reverse order. So the binary equivalent of this number is 1 0 1 1 1 0 1 1 1. So 375, this is our decimal number and its binary equivalent is 2. So 1 0 1 1 1 0 1 1 1. This is our binary equivalent. Let us consider one more example. 37. Again divide this 37 by 2. 2 ones are 2, 2 eights are 16, remainder is 1. Then 2 nines are 18, remainder is 0. 2 fours are 8, remainder is 1. 2 twos are 4, remainder is 0. 2 ones are 2, remainder is 0. Here the quotient will become 0 and remainder is 1. Write down the numbers in a reverse order. So when we consider decimal number 37, its binary equivalent is 100,101. So whenever we have to convert the decimal number into binary number, we have to divide the number by 2, and we have to go on dividing the number until we get the quotient as 0. For each successive step, we have to write down the quotient as well as remainder. And as we get the quotient equal to 0, write down the remainders from bottom to top. Means in a reverse order, we have to write down the numbers. And it is very necessary to write down the base over here. The base indicates that it is a binary number. Base 10, it indicates that it is a decimal number and it is a binary number. Okay, now we have to convert decimal number into octal number. Octal means there are total 8 digits. So we have to divide given decimal number by 8. For example, 79, it is the given number. Divide this number by 8. 8 nines are 72, remainder is 7. Again 8 ones are 8, remainder is 1. Here the quotient will become 0 because we cannot divide 1 by 8. So the quotient becomes 0 and remainder will be 1. So the octal equivalent is 117. When we consider the decimal number as 79, its octal equivalent is 117. Let us consider one more example. For example, 472. Again divided by 8. 8 5s are 14. 8 9s are 72. Remainder will be 0. 8 7s are 56. Remainder is 3. Again here the quotient will become 0. So we have to write down remainder as 7. When we consider 472 as a decimal number, its octal equivalent is 730 because we have to write down the numbers from bottom to top. Okay, chala. Now consider one more example. 68 divided by 8. 8 8s are 64. Remainder is 4. 8 ones are 8. Remainder is 0. Again here quotient becomes 0. So we have to write down 1 as a remainder and write the numbers in a reverse order. When we consider 68 as a decimal number, its octal equivalent is 104. Now we have to convert decimal number into hexadecimal. In hexadecimal, there are 16 digits and these digits are from 0 to 9. These are total 10 digits and alphabets A to F. Now here 10, decimal 10 is equal to A. 11 is B, 12 is C, 13 means D, 14 means E and 15 means F. You have to remember these 6 alphabets. Means from 10 to 15, we have to use alphabets A to F. Now we'll see how to convert given decimal number into hexadecimal number. For example, 523. Divide this number by 16. Why 16? Because we have to convert it into hexadecimal and there are 16 digits in hexadecimal number system. So divide it by 16. Here 16 3s are 48. Remainder will be 4. 16 2s are 32. The remainder will be 32 plus 10, 42 and 11. Write down the remainder. Again 16 twos are 32. The remainder is 0. Again here if we divide 2 by 16, the quotient will become 0 and remainder will be 2. We have to write down these numbers from bottom to top. But here we have to remember that 11 is equivalent to A. Sorry, 11 is equivalent to B. So for 11 we have to write down B and write these numbers in a reverse order, bottom to top. So when we consider 523 as a decimal number, its hexadecimal equivalent is 20B and it is indicated by base 16. 20B. Whenever the remainder it comes from 10 onwards, means 10, 11, 12 up to 15, we have to remember these alphabets. For 10 we have to use A, 11 we have to use B and so on. Now let us consider one more example. 751 divided by 16. 16 fours are 64. The remainder will be 11. This will become 111. 16 6 are 96. The remainder will be 15. Write down the remainder. 16 2s are 32. The remainder will be 14. Again, when we divide it by 2, quotient will become 0. So we have to stop the procedure. Write down the remainder. Now here, 15. 15 means your F and 14 means your E. So while writing the number, we will write down 751 decimal number. Its hexadecimal equivalent is 2EF and base 16. Okay. Now we have to convert the binary number into decimal. We have converted decimal to any other number system. Now we will convert any other number system into decimal number system. So first binary to decimal. For converting the number into decimal number system, we have to multiply it by 0th power of 2 and we have to go on increasing the powers. In case of decimal to binary, we divide number by 2. But in case of binary to decimal, we have to multiply by powers of 2. So let us consider the binary number 1 0 1 1 0 and 1. So from right hand side, we have to take the powers of 2. Means this will be 0th power, this will be first power, second power, third power, fourth power and fifth power. You have to write down these powers and then do the multiplication. 1 into 2 raised to 5 plus 0 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 square plus 0 into 2 raised to 1 plus 1 into 2 raised to 0. Now write down the multiplication and powers. 1 into 2 raised to 5 means 2 multiplied by 2 multiplied by 2 5 times. We will get 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. 2 multiplied by 32 plus 0 into 2 raised to 4. 2 raised to 4 is 16 plus 1 into 2 raised to 3 is 8 plus 1 into 2 square 4. 0 into 2 raised to 1 is 2 plus 1 into 1. Here 0th power of any number, 0th power of any digit is equal to 1. That may be 2 raised to 0, it is 1. 16 raised to 0, it is 1. 50 raised to 1, it is 1. So 0th power of any number, you have to write down 1. Then do the multiplication and addition. 32 plus 16 into 0, 0 plus 8 plus 4 plus 0 plus 1. 32 plus 8, 40, 40 plus 4, 44 plus 1, 45. So when we enter the number 101101, that is the binary number, its decimal equivalent is 45. Now let us consider one more example. 10110. Again write down the powers of 2 and you have to write down these powers from right hand side, from right to left. 2 raised to 0, 1, 2, 3 and 4. So 1 multiplied by 2 raised to 4 plus 0 multiplied by 2 raised to 3 plus 1 multiplied by 2 raised to 1, 1 multiplied by 2 raised to 1, here 2 raised to 2, then 1 multiplied by 2 raised to 1 plus 0 multiplied by 2 raised to 0. Now 1 into 2 raised to 4, 2 raised to 4 is 16 plus 0 into 2 raised to 3 is 8, 1 into 2 square is 4, 1 into 2 raised to 1 is 2 plus 0 into 2 raised to 1 is 1. So this will be 16 plus 0 plus 4 plus 2 plus 0, that is 22. So the decimal equivalent of this 10110 is 22. Now we'll convert octal number into decimal number. So 72, it is the octal number and you have to find out its decimal. Again here we have to multiply by power of 8, means power 0th power of 8, then first power, then second power and so on. So 2 means here we have to multiply by 0th power of 8 and here first power of 8. So 7 into 8 raised to 1 plus 2 into 8 raised to 0. So that is 7 into 8 plus 2 into 1. 0th power of 8 is 1. So 2 into 1. So it is 56 plus 2, that is 58. So whenever we enter the octal number 78, its decimal equivalent is 52. Sorry, last line फक्त परत इथे when we enter the decimal number 70, when we enter the octal number 72, its decimal equivalent will be 58. Now one more example, 5, 4, 3. Write down the powers, 0th power, first power and second power. 5 multiplied by 8 raised to 2 plus 4 multiplied by 8 raised to 1 plus 3 multiplied by 8 raised to 0. Now it is 5 into 8 square is 64 plus 4 into 8 raised to 1 is 8 plus 3 into 8 raised to 0 is 1. So here 64 into 5, that is 320 plus 4 8s are 32 plus 3. So this will be 320 plus 35, that is 355. So the decimal equivalent of 543 is 355. Now conversion from hexadecimal to decimal number system. Suppose the number is given 82. Here we have to write down the powers of 16. Means we have to multiply it by 0th power of 16, then first power of 16, second power of 16, so on. So here first is 0 and 1. So 8 multiplied by 16 raised to 1 plus 2 multiplied by 16 raised to 0. See, this is our hexadecimal number. So 8 into 16 plus 2 into 1. 0th power of any number is 1. Now 16 8s are 128 plus 2, that is 130. When we enter the hexadecimal number 82, its decimal equivalent is 130. Now consider another example. Say, let us consider some alphabets like A into B. AB, it is the hexadecimal number, and we have learned that A is equal to 10 and B is equal to 11. So here we have to multiply by 0th power of 16 and first power of 16. A means 10. So 10 into 16 raised to 1 plus B means 11. 11 into 16 raised to 0. Here we have to remember what does this A indicate, what does B indicate. You should know that. Then only you are able to convert the number into decimal number. And it is very simple, from 10 to 15, A to F. So A means 10, B means 11. So 10 into 16 raised to 1 plus 11 into 16 raised to 0. So it is 10 into 16 plus 11 into 1. So it is 160 plus 11, that is 171. Means when the number is hexadecimal number AB, its decimal equivalent is 162. Okay. So this is all about our number system. When there is a conversion from decimal to any other number system, we have to divide by corresponding digits. Means for octal, we have to divide it by 8. For hexadecimal, we have to divide by 16. And for binary, we have to divide it by 2. And when we have to convert any number system into decimal number system, we have to multiply by powers of that particular number. Means for binary, we have to multiply with the 0th power of 2, first power of 2. For octal, 8 raised to 0 means first power of 8 raised to 0 means 0th power of 8, first power of 8. And for hexadecimal, the powers of 16. So here we have discussed various types of number system and how to convert the given decimal number to any other number system, as well as the conversion from other number system into decimal. Means decimal to binary, decimal to octal, decimal to hexadecimal, as well as binary to decimal, octal to decimal and hexadecimal to decimal. Okay, thank you.